The next section, 6.4. 6.4 relates to what we were doing in the first three sections, so doing this will be kind of a review of some of the earlier stuff. But 6.4 is going to be percent increase. And when you're looking at percent increase, a good example of percent increase would be something like sales tax. So percent increase, basically what is that? That's when something goes up by a certain percent. The most common one that we have here in Michigan is going to be the sales tax. That if you go out and buy food like in a restaurant someplace other than a grocery store, you buy food where they serve it to you, you buy any non-food, so you buy new shoes or new skis or a skateboard or whatever, an iPod. You have to pay 6% sales tax on that now. They're looking at changing it to a higher percent. So if I were to go out and spend $100 on something, when I take it up to the register, they actually charge me $106 if they take and increase that price by 6%. You see that other places too. In college, I worked in a shoe store for a little over a year. And the shoe store, like for us, we get shoes or boots from like Vask or Timberland or wherever. And say we'd pay $100 to Vask for this pair of hiking boots, we'd sell it for $200 on the wall. That there was just a 100% increase in the price of everything that we sold. And then we'd get to keep that extra $100 to keep the store open to pay these employees and such. But there's going to be a couple ways to calculate it. One way is to go through and find, so say something's going up by 6%. One way to figure out what it is going to be is figure out, what's 6% of the original cost? So I buy something for $100 at the store. 6% of $100 is going to be $6. So you could figure out, okay, the 6% increase now is $6, and then add that to your $100. That's one way to do it. Another way to do it is just to do it all at one time. Instead of saying, what's 6%? Say, what's 106%? Because I still need to pay 100% of the item, but they added 6% on, so now I'm looking at what's 106%, and then just do it all in one step. And that's what I'm going to encourage you to do. So the way I'm trying to get you to do it is this. I'll put it in red for dramatic emphasis. Is yes. So it'd be $6 on 100. Okay. Then, all right, so I'd say when doing percent increase, comma, add 100% to the percent increase, then do the problem. If you go back to the very first one, I'm going to put a box around that middle part. That's the main thing. When you look at the first problem in the homework, the first problem in the book, it goes through and has you do it the other way, where you calculate, 6% is this amount, and then you go and add it to the total. And you're welcome to get in the habit of doing it that way. But this next section that we're going to do is percent decrease. That's going to be 6.5. And I think you'll just find that if you do it all in one step, it's going to make the problem shorter. It's going to make them easier in the long run. But I want to go back and do 3 examples, because like before, there's 3 places the unknowns could be. The unknown could be, what's the cost once you have this percent increase? They could say, you have to pay this much for an item after this percent sales tax. What was the original cost of the item? So it could be the original cost is what you're looking for, or it could be what percent increase do you have if this amount ends up costing you this amount. So we'll do 3 examples, and then we'll call it good from there. So my first example, so example 1, this is going to be where we're trying to figure out the total cost with the percent. And you could try to shorten up the story problem if you want to, but I'm going to say you buy skis for $400 with 6% sales tax. What's the total cost? We can set it up as a proportion, but I was trying to get you guys to do the problems this way, where we'd say the percent times the whole equals the part. This is going to be the one section where this doesn't make a ton of sense, because what's going to be bigger if we're doing 6% increase? The whole or the part? The part's going to be bigger, because we just went up from that. We had that whole amount. So if you wanted to, you could say instead the percent times the original equals the new. I don't know if it's worth trying to think of like a separate equation for these types of problems, but that makes some of them easier if you look at it that way. That whole is really just the original amount, and then the new is going to be the new cost, the cost with the 6%. So instead of 6%, we want to say 106%. If I do 106, this equation was one where we had to move the decimal. So the decimal goes between what two numbers? Yep, 1 and 0. So it's 1.06 because we have 106%. And then if you remember, when we changed it to a decimal, we always move that decimal point 2 places. Look familiar? And so 1.06 times the whole, or times the original, would be my 400. And if we would take 1.06 times 400, we'd get to that answer Adam came up with before, the $424. Should I show it the proportion way also? I'm getting one no. Other people, we're good this way? Or maybe I'll just show it this way for the proportion. I wouldn't write this down if I were you. I'll try to real quick whip through it. The other way that we were doing it was saying the percent divided by 100 equals the part divided by the whole. And if you wanted to, you could change that to the new over the original. And really this just, it's a little bit more work, but it does that moving the decimal for you. So we want 106% over 100 equals, we're trying to find that part, or we're trying to find the new. The whole was the $400. So we'd have 106, well, maybe I should write it out. So 100 times x equals 106 times 400. We're cross-multiplying there. And then to get x by itself, to get that new amount, we divide by 100. And if we did that, we should have had 424, or 42,400 divided by 100. Oh, almost hit the new page. So then we'd end up with $424. So push comes to shove, you can set it up as a proportion. But if you get into the habit of doing it that first way, it's going to make the problem shorter, make it a little bit easier. Any questions on that one? That's probably going to be the most common type of question that you'll see. But want to flip and do the two other examples too. So I'm going to unfocus. Example 2. I'm going to say the boots cost $152. So boots cost $152 in the store. If there's a 90% markup, if there's a 90% markup, before selling it, what was the wholesale cost? In effort to keep it short, I think I made my question confusing. What I'm trying to say is this, that the shoe store pays a certain amount to the vendor to get the shoe, then the shoe store marks it up 90%, and then they put it on the shelf for $152. So the $152 is after the 90% increase, is what I'm really trying to get at. So what's the wholesale, what does the store have to pay to the company to get the shoe? And so if we were to go back and say, all right, I have my percent. Should we do percent times original?
Yeah.
Okay, so percent times original equals the new. So the 152 goes in for percent original or new? New, because that's after the markup. So 152 goes on the right side of the equals. My percent, if it's a 90% markup, what do I put in my percent slot there? 190. How do I write 190%? 1.9. Nice. Because 90% markup, we're really saying, all right, they're still going to collect 100% of the cost of the shoe for them, but they're adding 90% to it, so we get 190%. And then to change it from a percent to a decimal, we always jump it 2 to the left. So 1.9 or 1.90 is going to be 190%. Times x equals 152. Yep. So then to solve it, we would divide both sides by 1.9. And when we do that, then we end up with x. The original cost is $80. So the shoe store pays $80 to get the boots or the shoes, and then they sell it for the 152. Second type of example seem to make sense? So if you're like me, I look at Trevor and I think, so what's the markup on bikes? What could they sell me that bike for? But I suppose they need to make a living too. And you might know, you work at a bike store. If you know, you probably shouldn't tell anybody. So what's the percent increase?
Well, I don't really...
So last example, what's the percent increase when something's marked up from $135 to, from 70. So what's the percent increase when something's marked up? Now I just need to redo my problem. From $135 to $187. I noticed in my last class that most people weren't writing out this first step. I really would encourage you to do the percent times the original equals the new. Writing that out is going to help you, and it doesn't take long. All right, so we're looking for the percent. So I could right away put my x right in there for the percent. The original cost is going to be $135. To my new cost, which is the 187. Now to solve that for my x, because x was multiplied by 135, we're going to do the inverse. We're going to divide. And then x, my percent, we pop that into a calculator, 187 divided by 135, gives me 1.39 with a little bit of rounding. So actually I'll write the whole thing, 1.385. What in the world does 1.385 tell us?
There's 138.5.
So it's 138.5%. So now the markup is
138.5%.
Well, the 100% was just that original amount. The actual increase, though, is 38.5% increase. That's it for the section.